Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X published on November 23, 2025, about 4 days ago. It proves a linear time algorithm that extends the classical Chairman assignment guarantee to arbitrary weights, and then leverages that to get a 3-1 over m-1 approximation for minimizing maximum flow time when machines have closing times. The paper is titled Weighted Chairman Assignment and Flow Time Scheduling. And as we will see later, these discrepancy bounds quietly power some surprisingly strong guarantees for complex scheduling systems. Alright, Figure 1 illustrates how the assignment problem becomes a single-source unsplittable flow instance on paths. A single-source node S sends flow along 4 parallel paths, one for each chair I, split into copies I, 1 through I3, that correspond to prefixes of jobs. Each black square, T1, T2, T3, is a terminal that demands total flow equal to the weighted size of its job. Flow on each horizontal arc encodes a prefix sum of xij times dj, so prefix discrepancy translates directly into respecting arc capacities. So, while Figure 1 tied discrepancy to flows on paths, Figure 2 illustrates why scheduling with machine closing times can be tricky. The left panel shows the naive first-in, first-out policy, which spreads each job batch across all still open machines and accumulates a large maximum flow time. The right panel shows the optimal policy that sends each batch entirely to a single compatible machine, so every batch finishes much sooner. The contrast visually explains the logarithmic gap between naive scheduling and the carefully chosen assignment. Well, the current figure presents a structured fractional assignment matrix that underpins the tight lower bound. Rows correspond to m machines, columns to m-1 jobs, and most entries share the same simple fractions, like 1 over m-1 or 1 over 2 meters minus 2. Several entries are boxed, which highlight where any integral rounding is effectively forced to place whole jobs. This pattern shows that, even with such regular fractions, some row will inevitably accumulate discrepancy close to 1/2. Alright, while the previous figure highlighted a combinatorial lower bound, Listing 1 presents a straightforward mixed integer program that computes the optimal discrepancy value directly. The code defines binary assignment variables and a non-negative delta that measures worst-case interval discrepancy. Constraints force each job column to choose exactly one machine, then bound every machine and every time interval, so the weighted difference between x and y never exceeds delta. The solver then minimizes delta, returning the best possible discrepancy for that fractional input. So the big picture is that this research extends the classic Chairman assignment guarantee to fully weighted settings with a simple linear time algorithm, and then turns that combinatorial insight into a near 3 approximation for tricky flow time scheduling with machine closing times. These tools could shape future work on robust routing and deadline-aware scheduling. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.